I'm Muhammad Umair Munir. I'm a civil engineer by profession, and the topic of my discussion today is sustainable water resource management in biofuels. To understand the link between the two, we need to appreciate the fact that the world has gone through rapid advancement in the recent decades. And this development in turn has resulted in depletion of all our resources. If we continue progressing and using the resources at the same place, we might end up using all the resources and there will be very little left for the future generation. Sustainability is a very broad term and it can be defined as meeting the needs of the present without compromising the ability of future generations to meet their own needs. In order to ensure that, about 17 Sustainability Development Goals were adopted by the United Nations back in 2015 as a universal call to protect the planet with a target date of 2030. Out of these 17 goals, number 6 and number 7 relate to sustainable water and energy management for the world. Let's talk about water scarcity. Water scarcity is the lack of freshwater resources to meet the standard water demand of the people. There are two types of water scarcities, namely physical and economic water scarcity. The figure here shows the different areas of the world which are suffering from physical and economic water scarcity. Now, talking about the bioenergy, it is a form of renewable energy generated by burning biomass. The matter of fact is that bioenergy related water use can intensify existing water stress. What does that tell us now? It tells us that there is a clear need of regulating use of water for production of bioenergy and other renewable energy sources. The research paper which I selected for my presentation, it relates to taking into account water use impacts in the LCA of biofuels. It's an Argentinian case study. The reason I selected this research was it's published in the International Journal of Life Cycle Assessment, it's peer reviewed, it's got a clear environmental problem which is related to water use in biofuel production, and it uses LCA to compare different situations. The research paper calculates the water consumption and overall life cycle assessment results in a case study for the production of methyl ester from irrigated and non-irrigated lands for rapeseed cultivation. The research mainly calculates two scenarios for the fossil fuel reference. The first, using the impact factors of Mendoza to stimulate a water-scarce region in Argentina, and the second with the average impact factors of water-rich areas like Entre Rios, Argentina, to stimulate a low-scarcity region. They are then compared with other regions like USA, China, and Brazil. It uses the eco-indicator 99 method for overall impact assessment. The impacts of water consumption are assessed with the method of Pfizer et al. 2009. The results in this research are calculated over the whole life cycle of the different fuels. The functional unit is considered to be 1 person kilometer transported in a car. The system boundaries include the production, transport, and the final use of the fuels. The inventory for the cultivation phase is based on the data collected from Mendoza and Entre Rios, Argentina. If we compare this research to our group assignment, we used LCI database or LCI 2021. However, to establish the sustainability performance indicator and life cycle impact categories, Recipe 2016 midpoint H was used. There has been a similar research recently on water footprint of using microbial algae for biodiesel production. It did not use LCA as the scope of study was limited to indoor microbial algae production only. This research had some limitations as well. One of them was that it relied on the method Pfizer et al. 2009 for water consumption assessment. This method evaluates only consumptive water use, while the EcoInvent data considers the total water withdrawal. The second one was that due to limitation of some database available at that time, the research had to estimate water consumption used in cooling and industrial production, considering 10% of the total water withdrawals. The graph here summarizes the three main environmental impact categories for producing biofuels using different sources. namely acidification, land use, and water consumption. The study clearly shows that producing biofuels can reduce the fossil fuel use and greenhouse gas emissions when compared to fossil fuel reference. It is important to notice, however, that higher impacts in other categories in the biofuels studied here led to shift in environmental problems, mainly towards impact on ecosystem quality. These results indicate that there may be a trade-off between land use and water consumption while we produce biomass using different resources. Biofuels is usually visualized as a green solution towards maintaining sustainable energy demands of the world. This perception might lead us to neglect many other relevant environmental impacts, which may provide misleading incentives. In fact, water use, in addition to land use, could become a major concern offsetting the benefits of biofuels. As a conclusion, I can clearly state that bioenergy related water use can intensify the existing water stress and water scarcity related issues of the world. The results of the study clearly demonstrate that the overall environmental impact of irrigated rape methyl ester was 3 times as high in Mendoza region than other non-irrigated areas of Argentina, purely because of the use of irrigated water. Hence, sustainability in producing biofuels can be improved by using feedstock which requires less irrigation water, as it brings down the water consumption of the overall process. Thank you, and the references are in the next slide.